Good evening,
Good evening.
sir.
Yeah, good evening, Yukta.
Good evening, sir.
Yeah, good evening. Just in 1 minute, we are starting. Let
Sir,
everyone
physics
join.
or chemistry today?
Today, in the last class, we did
Chem.
physics or chemistry. What did we do in the last
Sir,
class?
we did the chemistry. You told us about the Bohr's model of an atom.
Yeah,
And we completed the, you also told us about the atomic mass and mass number.
all right. Okay, just.
So we're
So
doing work and energy today, right? The remaining
today we'll be doing work and energy. All right.
So the remaining questions from NCRT?
Yeah, the remaining questions from NCRT. All right.
Okay, sir. Sir, I had one question.
Yes.
Sir, do you have any sample paper for science?
Yeah, I do have sample papers.
Sir, can you send one to me for practice?
Okay, we'll be uploading it to the group to the Wise app only. I'll just tell sir or inform him. Okay, to
Yes,
upload
sir.
the sample papers. Okay,
Yes, sir.
all right.
So just assertion and reason I'm finding a little tough.
Assertion and reason. Yeah, they are tough actually. They are tough. All right.
Sir, but it's just understanding the concept, right?
Yeah, if you understand, if you are able to understand the concept, if you are able to get it in the right way, so then you'll be getting
Sir,
it.
and one more thing, after we do NCRT questions, can you give us that pendulum thing related to work and energy? Like, can you just explain?
Okay, so today only I will explain that pendulum.
Yes, sir.
Okay. So I think we were doing in the last class the same topic, conservation of energy.
Uh, Sir, I think, yeah, you gave us some questions also from NCRT, the exercises.
Yeah,
So we're only left with power, right?
we have to.
We're only left with power after this, right?
Yeah, we are only left with power. So we'll be doing some questions and then we'll do power.
Yes, sir.
Okay, so I think everyone is joined.
Yes, sir.
Okay, let's continue then.
Sir,
Good evening, sir.
Sir, can I send one question from my reference book to you after class is over?
You can send it right now. Okay,
Yes,
you can
sir.
send it right now. We'll be discussing
Sir,
everything.
it's related to work and energy.
Okay, so see, we had done here conservation of energy or
Yes, sir.
conservation of mechanical energy, right?
Yeah, sir. Yeah.
And in this topic, we were doing the working of simple pendulum. How does a simple pendulum work? Okay, so first of all, we'll observe the motion of a simple pendulum. How does a simple pendulum move? And then we will see what are the energy changes that are occurring in a simple pendulum.
Yes, sir.
Okay.
Sir,
Yes.
the pendulum comes as a case-based question, right?
Yeah. Pendulum may come as a case-based question, may come as numerical also. You can get numerical also based on it.
Okay.
Okay, so let's see how the pendulum moves. First, we'll see the motion of a pendulum.
Yes, sir.
So let's say motion of pendulum. We'll see how it works.
Sir, it goes from the extreme positions to the mean position, right?
Yeah, it goes from one extreme position to the other extreme position. All these. Let's see. Okay, so see here, I think it shows you clearly how the pendulum is moving. The pendulum is moving between the two extreme positions. I think
Yes.
everyone can see the motion of this pendulum.
Yes, sir.
Okay, I'll try to mark here the extreme positions.
So that's extreme.
Yeah.
That is also extreme. So, sir, the point where it ends is the extreme position, right?
Yeah. So that those
The
are the
start
extreme
to
positions.
stop and then stop to start.
And this is the mean position.
Mean.
All right.
Yes, sir.
So see, okay, can you see that when it is at the mean position, it's faster, and it momentarily comes to rest when it is at the extreme position.
Yes, sir.
Okay, so we'll see what happens to this motion.
Yes, sir.
So see, this is one of the extreme positions. So see, so if you see the level, so this is the horizontal level, all right?
Okay.
And from the horizontal level, when it is at the extreme position, it is at a certain height.
Right. So MGH is present.
Yeah. So at this point, it has the energy which is given as the potential energy, and it is
MG.
equal to mgh. Also, we observe that momentarily it comes to stop. Momentarily it comes to rest.
Yes. So KE will be 0.
Yeah, the Ke will be 0. So at this point, you observe that the kinetic energy will be equal to 0.
So, sir, if on one extreme position it's MGH, so on the other also it's the same, right?
Yeah, on the same, it is the same both the sides. So here also you get the same height h, that is potential energy mgh, but the kinetic energy to be 0 at this
0.
position.
Yes, sir.
Niharika,
Yes, sir.
good evening and welcome, Niharika. So I think this is your first class. I hope you tried to join the last class, but you could not.
Yes, sir.
Okay, this is your first science class, right?
Yeah, sir.
Okay. So here we are doing this chapter work and energy. And in the chapter work and energy, we are doing the topic conservation of energy. Okay.
Okay.
So first of all, tell me, have you done anything with this chapter earlier?
Sir, we're doing the same chapter at school.
Okay, okay. So I don't think that you'll find much difficulty in understanding these concepts. So just to add up, I'll just quickly guide you with what is potential energy and what is kinetic energy. Right? So the potential energy of a body is the energy of a body possessed due to its position or shape. Okay, so potential energy, it is the energy of a body possessed by a body due to its position or shape. That means wherever the body is, that gives it, uh, if it provides any energy, so that is the potential energy. For example, here we see the body is changing its position. So from the ground level, from this position, it is raised to a certain height, and hence we can say that it is gaining some potential energy. We can also see potential energy due to shape. For example, in case of a spring,
So,
if you
rubber
take
band is the best example for shape, right?
rubber
Stretching
band,
of a rubber band.
we generally don't consider. All right, there are
Wait,
regions at high levels we don't consider rubber band.
Oh,
See,
okay.
as rubber band is a material which we call elastomers.
Sir, it has elastic potential energy, right?
It has elastic potential energy, but it is called elastomer.
Elastomer.
Yeah, it does not
Okay.
obey Hooke's law, which is an
Okay.
important law. Does not obey in Hooke's law. In the case, it's not perfectly elastic, you can say. All right.
Sir, I
So
had one doubt.
yeah, obviously the rubber band has potential energy. When you stretch it, it has potential energy. Okay, there
Sir,
is
I
no
had
doubt.
one doubt.
Yes,
Sir, will they ask cos theta questions or most likely they won't?
most likely the cos theta questions are not asked, but to be prepared for the worst.
Sir, I remembered it, but my other teacher in school was saying because you can only understand it after we learn trigonometry in 10th.
Yes, so that is why. But you should you should always be a step ahead.
Sir, I remember the values of the cos theta, so I don't have to worry.
Okay, so that's why you have to be just a step ahead.
Yes, sir. Sir, but they'll mention the values of the thetas, right?
Yeah, they will mention whenever it's there. They will mention.
Okay.
So
Sir, but
okay,
here K is 0, but in some cases they can also be at a certain height, right?
yeah.
The
Just 1 minute.
pendulum.
Let me explain Niharika. I was explaining her about potential energy. Okay. So we'll come back to the topic. Okay, so Niharika, if you look up at a spring, so when you extend a spring, so this is just normal length of the spring. If you extend the spring like this, so we see that we have changed the shape of the spring, right? By changing the shape of the spring, we say that the spring has obtained potential energy.
Yes, sir.
Okay. Similarly, by compressing a spring, if you compress this spring to be like this, a very small one, so then also it will have potential energy. So such objects, they have potential energy due to the change of shape. For example, a balloon. If you are inflating a balloon, you are changing the shape, and what energy is there?
Potential energy.
Potential energy, all right? So there is also potential energy in it. Everywhere, wherever you observe a change of shape or change of position, that gives us a potential energy. Now, the kinetic energy is the energy possessed by a body due to motion. So any moving body possesses an energy that we call as kinetic energy. So we call it energy due to motion. The
Yes.
expression for kinetic energy is given as 1 over 2 mv square. And for this potential energy which we are studying here, this we are studying as the gravitational potential energy, which is given by the formula mgh. So in this chapter, mainly we'll be studying about the gravitational potential energy. Okay, not the elastic potential energy. So this is potential energy gravitational, which is mgh, where m is the mass of the object, g is acceleration due to gravity, and h is the height up to which the object has been reached. For example, if you are raising one object from this level to certain level h, so the work done or the potential energy here will be equal to mgh. This will be the horizontal level from where you have lifted to a height h. So you can say that at this point it will have the potential energy as mgh. Got it?
Yes, sir.
Okay, so can we continue here?
Yes, sir.
Okay. So when we say conservation of energy, or we are talking of conservation of mechanical energy, we see that the total energy of the system remains constant. It only gets transformed from one form to the other. So here, when you are taking the bob to the extreme position or this mass to the extreme position, so when it reaches the extreme position, it has zero velocity. Okay, so therefore at the extreme position, since its velocity is zero, therefore its kinetic energy should be equal to zero. So at the extreme, its kinetic energy will be equal to zero. And when you are at the mean position, its kinetic energy will be 1 by 2 mv squared. So at the mean position, here the kinetic energy will be 1 by 2 mv squared. And at the extreme position, the kinetic energy will be
half
0.
m squared.
Again half mv squared, but velocity is 0 at the extreme position.
So half m, no, velocity is 0, so only 1 by 2 into m
1 by 2 into m into 0, so that makes
into
it
h
0.
minus x, right, sir?
Oh my God, I was talking of potential kinetic energy at this point. So
Okay.
kinetic energy at this point will be
mgm.
equal to 1 by 2 m times of v squared. So v is 0. So you
Okay,
get your answer as 0.
0. Oh, my bad. Yeah. Oh, okay, sir.
Okay. So at the extreme position, you are having only the
0.
potential
Only
energy.
potential energy.
Yeah. And at the mean position, the height becomes 0.
So only mg?
No, not mg. At the mean position, if you see, so I will find its potential energy, which will be given as mg times height, and height
So
is
0,
0.
0. So potential energy 0.
Yeah. So at the mean position, you are getting the potential energy to be 0, but it has gained some velocity. See, if
So
it moves through
kinetic
this,
energy will only be present.
yeah. So at the mean position, it is having kinetic energy,
And
and
at
at
the
the
extremes,
extreme,
it has potential energy because some
yeah,
height is present.
yes. And at anywhere in between, it possesses both potential as well as kinetic
Kinetic.
energy.
So, sir, in between, will it be the sum, will it be the mechanical energy, sorry, of Potential.
Everywhere we are talking of mechanical energy only.
No, sir, like I'm asking in between, you said there'll be both, right? So we have to
Yeah,
add both the energies, right?
yeah, you have to add both. Even if you add at extreme position, you will get the same thing. If you add at the mean position, you'll get the same thing.
Okay.
At every point, if you add the potential energy and the kinetic energy, you'll
We'll
get the
get the
same
same thing.
quantity. Okay, so see, if you observe it, so at the mean position, it's moving faster.
Faster.
Okay, and at the extreme position, it's slower. Any pendulum, if you observe, so it's like this only. As it reaches towards the extreme, its velocity becomes zero. As it comes towards the mean, at the mean, it has high velocity. Got it?
Got it, sir.
Okay. So, any doubts to anyone in this pendulum, understanding the pendulum?
So, sir, at the extreme positions, it's mgh, and at the
Hmm.
mean position, it's half mv square.
Yeah, at the mean position, it's only half of it. As
Okay.
the potential energy becomes zero.
Right, sir.
Okay.
Sir, if it comes as a numerical, will we do we have to draw the draw the setup?
We'll see the numerical if it's there.
Yes, sir.
Okay. It depends on the numerical what it asks. However, it is always good to draw the diagrams. Alright. The similar thing happens with the roller coaster also. The similar thing happens with the dam also. Can you explain the conversion of energy in a dam?
Sir, in
Dam.
sir, potential energy, right?
Okay, so a dam utilizes for a dam at a certain height, water is stored in a reservoir. So here, water is stored in a reservoir, and from there the water is allowed to fall down. Okay, so from where the water is allowed to fall down. So when water falls down, it falls with a speed. So here it was at a certain height. So this difference of height, it gives it potential energy. So here it has only potential energy, and when it reaches the bottom, it has kinetic energy. Alright, so it's moving, it has kinetic energy, and this kinetic energy is getting converted to the electrical energy with the help of turbines. So you have turbines installed here which convert it to kinetic energy, which convert it to electrical energy. Okay. A similar thing happens with the roller coaster also. A roller coaster, if you see a roller coaster, the people sitting on a roller coaster, they are taken to a certain height and released from there. So if they are released, so their potential energies are getting converted to the kinetic energies. All right. So I think we are covered with this energy. Yes.
Sir,
Yes.
I had a doubt in the roller coaster question in my
Yeah.
diary.
Okay. What's your doubt?
Sir, can I send the question to you after class is over?
Yeah, you can. But if you send it right now, I'll discuss it.
Yeah, sir, I'll send it. Just a
Okay.
minute.
So see here, the expression we got as the sum of potential energy and kinetic energy will be a constant. If you observe the conservation of energy, so the sum of potential energy and kinetic energy will remain constant. Okay, so the next topic is rate of doing work that we call power. So this is the last topic from this question, from this chapter.
Yes, sir.
So rate of doing work. Rate of doing work means how fast someone is doing a work. Okay. See, the amount of work done, it depends on the amount of energy that is there. So you can say that work and energy, they are interconvertible, which we studied as work to be equal to the change of kinetic energy. Or we say that the work and energy, they are equivalent. But now the rate of doing work, it is, or it tells how fast work is done, or how fast energy is consumed. So how fast the energy is consumed or how fast the work is done, that we call as power. So
Wow.
you can say rate of doing work is power, or you can also say the rate
Okay.
at which energy is consumed is called power. Okay. So just think with it an example which I made myself. So consider a fat person and a thin person. Right. So who do you think will have a greater storage of energy in his body?
So
In the form of chemicals, like in the form of glucose, in the form of fats, who
third
has
thin
greater
person.
amount of energy in his body, a fat person or a thin person?
So I think thin person.
How?
Sir, because
Okay, who has a greater body mass?
fat person.
Fat person. And the body mass consists of the glucose molecules and the fat molecules, all the
So the
molecules
fat
which are
person
there.
will have more power.
Yeah.
So the fat person will have more power.
No, I'm not talking of power. See, I'm talking of energy. Who
Energy,
has a
okay.
greater energy?
Fat person, sir.
Yeah, the fat person is having the greater energy. Okay. So the fat person here is having a greater amount of energy. What about the thin person? He's having less
And
amount of
amount
energy.
of energy.
Okay. Who can do a greater work? Suppose I want to lift a 50-kilogram object. So who can lift this?
So
Who
the
is likely to lift?
fat person.
The fat person. Since he has greater energy, so he can do more work. Understood, everyone? Niharika, have you understood?
Yes, sir.
Okay.
So,
Yukta, Harshit.
so the fat person will do more work.
Yeah, he will do more work. All right. Sampath, do you agree with this? Sampath, Pranav.
Yes, sir.
Yes, sir. Shravan. Sir, I agree. Okay. So the fat person will do more work since he has a more amount of energy. Now suppose I want them to do a piece of work.
Sir, some.
Yes. Some piece of work, like suppose it may be like I want them to run a certain distance. It may be like I'm giving them some bricks to put them from one place to another. Now who is likely to do it faster?
So the thin person.
The thin person will be able to do it faster.
So because of less body mass.
Yeah. So see, how fast you are doing the work, that is your power.
Yes,
And
sir.
how much energy you are consuming or how much work you are doing, that is
That's
your
the
work done
yeah.
or energy. What the difference between energy and power?
So power is rate of doing work, but energy is the work being done.
Yeah, energy is the work being done, whereas power is the rate of doing work. How fast you are doing the work.
Yes, sir.
Got it, Harshit?
Yes, sir.
Okay. So see, we can write the formula of power here. We can write power to be equal to
Work by
work over time. Or we can also write it as
T
energy
by T.
consumed per unit time. Energy per unit time will be called as power. Or work per unit time will be called as power.
Sir,
So, yes,
when is power considered to be force into velocity?
we will come to when we consider power as work times velocity.
Yes, sir.
Alright, power is work times velocity.
So force times velocity, right?
Yeah, power is force times velocity.
Okay.
So now, what is the unit for work or energy?
Sir, watts or joule,
Work or energy?
joule per second?
Joule. Work or energy is measured in joule,
Sorry, joule.
and your time is measured in second. So the SI unit of power will be joule per second. Rohit, you don't hear the questions.
Yes,
So you are
sir.
in so a hurry that you don't hear the question.
Yes, sir.
Okay. So providing the correct answer is the thing that gets you marks.
Yes, sir.
So we
I'll be
say
there.
that power is given as, or SI unit of power will be joule per
Yes,
second.
sir.
The work or energy will be measured in joule.
Joule.
The time will be measured in second. So power will be measured in joule per second. All right. So joule per second is also called as
Watt.
watt. All right. So joule per second is what we call as watt. This is watt. So I think now you should remember the formula of power to be work over time or
Mm.
energy over time. And the physical significance means how fast you are doing your work. For example, at your home, you have two water pumps. Okay, consider you are having two water pumps. So one of the water pump has a power rating of 250 watt, the other one has a power rating of 750 watt. So which one should fill your tank faster? Did you get my question, Pranav? Pranav, did you get the
No,
question?
sir.
You have two water pumps here at your home. You are having two water pumps. The water pumps, you have two water pumps, one rated 250 watt, the other rated 750 watt. And suppose you have to fill a tank of 1000 liters. So which one will fill faster?
750 watts.
750 watt. All right, as it has the higher power, so it can do faster work. All right. So the 750 watt motor will be doing a greater amount of work. Now see, this we now know that the SI system of power is watt, which is joule per second. Earlier units which were used with the common those times, they were horsepower. So in older times, the other units which were used, they were horsepower.
Horsepower. Yeah, sir. Horsepower.
Yeah, horsepower. We say HP, which means horsepower. So even now you hear somewhere word like horsepower. So like if you talk of the power of your car engine, generally you
HP.
talk of it in horsepowers. Okay, how much is the horsepower capacity of that engine? Some of the people they even talk capacity of water pumps in horsepower or HP. For example, a water pump having a capacity of uh, 1 HP, a water pump having a capacity of half HP, 2 HP. Okay, you might have heard these words commonly being used by some people at your home. Have you heard these words?
Sir, I've only heard it. I've only heard it in the vehicle engines.
Yeah, in vehicle you have heard. Okay. So also if you since you haven't ever been to the electric motor shop or over there, so you don't know about the terms related to the electric pumps. All right. So these are the words which were used earlier. Horsepower based on the power that is given by a horse. A healthy horse, that whatever power, average power is given by that is called as a horsepower.
Power.
So 1 horsepower is now termed to be equivalent to 746 watt. So now it's found to be equivalent to be 746 watt. Okay, so you got your conversion between horsepower and watt.
So 746 watts, right?
Yeah, 746 watt. 1 horsepower equals 746 watt.
Sir, can you also give conservation to joules for watt?
Conversion
From watt to joule.
to, okay, how can you convert watt to joule? Watt is a unit of power and joule is a unit of energy. Okay, they are two different things. A horsepower, a watt, and joule. So horsepower can be converted to watt, but you can't convert watt to joule.
So, sir, kilowatt can be converted to joule, right?
Yeah, kilowatt.
Yeah.
The same power can be power which is given in watt can be converted to kilowatt. For example, consider a device having a power of 1500 watt. Okay, so what will be its power in kilowatt?
Sir,
Yes, Ravan, can you convert this to kilowatt?
So 1500 plus 746.
No. See, okay, I hope everyone knows that 1 kilogram is equal to 1000 grams, right?
so 15,000 kilowatt. No. 1 second, sir.
See, 1 kilogram is 1000
1,000
watt,
grams.
1000 gram. Okay, or you can say that 1000 gram is 1 kilogram. So, in the
1
similar
watt will
way,
be 10 to the power 3 kilowatts.
just 1 minute. 1000 watt is equal to 1 kilowatt.
Yes, sir.
A kilo means 1000. So 1000 watt is equal to 1 kilowatt. Therefore, 1500 watt
Will
will be
50.
equal to
1.5 kilometers.
1500 over 1000, which turns out to be equal to 1.5.
1.5.
Right, so this is 1.5 kilowatt. Got it?
So 1,000 watts is 1 kilowatt.
Yeah, 1000 watts is 1 kilowatt. Got it?
Sir, so horsepower can be converted to watt and watt can be converted to kilowatt, but watt cannot be converted to joules.
Okay.
Yes, sir.
What can be converted to joule?
Sir, Newton meter?
Okay. So everyone got this convergence? Anyone having any doubt with this convergence? Niharika?
No doubt, sir.
Okay. So now we come to energy and we'll reuse this relationship to find out energy. So see, you write since we can write power to be equal to work over time, or we can write it to be equal to energy over time. So if you transpose time to the other side, you can rewrite the formula of work as to be power multiplied by time. Okay. And you can also write the formula of energy to be power multiplied by time. So you see,
Yes.
work and energy, they are the same thing.
Right, sir.
Okay. So just tell this answer. I am giving a question. Bulb of 60 watt is used for 10 minutes or used for 5 minutes. Find the energy consumed. Can you tell the energy consumed?
Sir, uh,
Find out the energy consumed.
sir, I had one doubt.
Yes.
Do we leave it in watt per hour only or watt per minute in this case?
What units you have learned?
Sir, watt,
Hmm.
seconds?
Watt second. Okay. Which is the same as joule?
Yeah, joule per second.
Not joule per second, joule.
Joule, yeah.
Watt second is joule. Okay. So use this. Do this, everyone. I want the answer from everyone. Shravan,
300
Niharika.
watts.
How much?
300 watts.
800. Huh?
No, not 300.
Sir, no. Sir, 0.2.
0.2.
Sir, because 5 minutes in seconds is 300.
5 minutes in 3 seconds is
5 minutes in seconds is 300 because 60 into 5.
hmm.
So 60 by 300.
Yeah.
So 1 by
Shravan.
18,000.
Okay. So see, you convert everything to SI unit. Your power is in watt. That's correct. Your
There is
time is given as
18,000.
5 minutes. So you write your time, which is given as 5 minutes, convert it to seconds. So this you get as 5 times 60, which we say 300 seconds. So energy will be power times of time. Power is 60 times of 300. 60 times of 300 is 8. And here you have
18,000.
1, 2, 3. 18,000 joule. Since you are using SI units, so you'll get your answer in SI units. Got this, everyone?
Got it, sir.
Okay. Now see, assume we got here just one bulb, 60 watt, is used only for 5. And see how much energy is being consumed over here. Yes, Shravan? So you can think of if you are using a bulb for 10 hours per day and for 30 days, you can assume how much of energy you will consume. Okay, it will be millions of joules approximately. Alright. So this is for scientific or small measurements that we use joules. For other purposes, we use we use commercial unit of energy. So next we study here commercial unit of energy. We need some better unit. Okay, better unit for selling and purchasing. So do you ever purchase energy? Yes, anyone?
Sir, electricity bills. No, sir, we don't purchase energy.
Okay. Do you ever purchase energy, Niharika?
So, electrical energy we purchase.
Do you ever purchase energy?
Yes, sir.
Yes. So when do you purchase energy?
When you're paying your electric bill, you're purchasing.
Yes, when you are paying your electric bills, you are paying for the energy.
Huh?
When you are paying for the energy, that means you are paying for your electric bills, that's energy. When you are paying for the gas, cooking gas, you are paying for the electrical energy. Alright. So commercial unit of energy. That means whenever we are purchasing energy, whenever we are selling energy, we will be measuring the energy in those units. So the commercial unit is called kilowatt. It's a kWh, that is kilowatt hour. And see, to understand this, there is a very simple criteria. And the criteria is that you measure your power in kilowatt. Okay. Like if you use this formula of energy, see, use the formula of energy to be power multiplied time and measure the power in kilowatt. So if you are measuring your power in kilowatt, this power is measured as kilowatt, and the time for which it is used, you measure that in hours. Right? So then the energy that is consumed, it will be measured as kilowatt hour or kWh.
Yes, sir.
For example, for this question only, suppose if I find out the energy consumed in kilowatt hour, so let's see how much of the energy is being consumed. So for this previous question only, now I say the power of the bulb is 60 watt. So I'll be converting this to kilowatt. And to convert it to kilowatt, you get it 60 divided by 1000. So 60 divided by 1000, 60 divided by 1000, you get 0 and 0 cancel. So this becomes 0.06 kilowatt. Right? And you are given your time in minutes. So convert that time to hour. So your time getting converted to hour. Time is 5 minutes. So this 5 minutes becomes 5 divided by 60 converted to hour. Okay, so this is 1/12 of an hour. Got it?
Yes, sir.
Okay. So your energy will be measured as power, which is 0.06 multiplied with 1/12. Okay. So in kWh, this energy, you can see how small the energy now becomes. You get 0.06 multiplied with 1/12.
So which becomes
Yes.
6
So
by
it becomes
12.
0.005 kilowatt hour. All right. Now we'll do one more question. Don't get doubt. I will clarify every doubt. Okay. So this question should clarify all your doubts. You see. Find the energy consumed. Find the energy consumed by a bulb of 60 watt if it is used for 6 hours daily for 30 days. All right. So, how many of you can think that attempt this question? You have to find the energy in kilowatt hour. Yes, who all think that can do this question? No one?
Sir, I'll try.
Okay, you try. What about Pranav? Pranav? Pranav,
Yes, sir.
you are not asking anything. You're not responding. क्लास ले रहे थे अभी 10 मिनट है उसके बाद 8 बजे है देखना स्टूडेंट्स बोला था आज नहीं रहेगा तो अगर आ जाएगा तो ले लेंगे नहीं रहेगा तो नहीं लेंगे पीटीए अच्छा मैं ज्वाइन करूंगा ठीक ठीक ज्वाइन करूंगा ठीक ठीक ठीक, अब लिंक शेयर करिए। ठीक 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 है सर, बिल्कुल बिल्कुल आप शेयर करिए। Alright, so anyone Pranav, how to do this? Harshit, Sampath?
Sir, I think I understood.
Okay, so okay, you got it, you do it. Pranav, Shravan?
Sir, I'm still doing.
Okay.
So we should
See, the first step is, your first step is convert your power to kilowatt. Okay. So your power given here is 60 watt. You convert to kilowatt. Sampath? 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 Harshit?
Yes.
Okay. Divide it by 1000 and get the answer in kilowatt. Okay. So divide it by 1000. You
So
get 0.06
0.06 kilowatt.
Okay, 0.06 kilowatt. Now your time has to be taken in hour. So what is the time that for which the bulb is used?
There's
6
6
hours
hours
per
daily
day.
for 30 days. So 30 days we can convert into 720 hours.
No. 6 hours daily.
So
That means
6
in
only.
one,
So 0.6 into 6.
no. In one day it's 6 hours and it is used for 30 days. So
So
your
30
time will
into
be
6, 180.
30 times of 6.
180.
Okay. Okay, so it will be 30 times of 6 or 6 times of 30, which you take at 180 hours. Okay. Now you find the energy. So energy will be power multiplied time, which will get as
10.8.
0.06 times 180. Okay. So I think you get the answer as 9 kilowatt hour. Just
So I'm
check it.
getting 10.8.
10.8.
Yeah.
Yeah, 10.8.
So
Yeah.
can we take it as 11 approximately?
No. 0.06
So
times
10.8 kilowatt per hour.
Yeah, it's 10.8 kilowatt hour. Got it?
Yes, sir.
So this kilowatt hour is also called as unit. We also term it as unit. Yeah, Rohit, what's
Sir,
your doubt?
sir, I actually did 13 to 24, so I got the answer wrong. I corrected it.
Okay. Niharika, did you get the answer?
Yes, sir.
Okay. Now here in this one only I am adding something. Now you will tell me. How much should I pay? How much should I pay if how much should I pay if we have cost of energy is rupees 6 per kilowatt hour. So who can find out the cost?
Sir, I got it.
Okay, all right. So the cost will be 10.8 times of 6.
64.8, sir.
Okay, so you got 10.8 times 6. This we get here as 64.8 kilowatt hour. 64.8. Oh, not 64.8, just multiply 10.8 with 6. Yeah, 64.8 rupees, right?
Yeah, rupees 64.8.
Yeah. So this is the amount of rupee that you have to pay. Got
Yes,
it?
got it.
Okay, so I'll just give you a few questions which you can try. You can try this question I'm adding here. You can either take the screenshot or you can refer your NCERT for this question. You have to do question number 17 and you have to do commercial. From the commercial unit, you will be doing this one. Mm. See, you need to do question number 20. All right.
Your homework.
Okay. So I am adding here. You can take it from here or refer your NCERT. All right. Thank you. Bye everyone. We'll see you again in next class.
Yes, sir. Thank you, sir.
Okay.
Bye, sir.
Any doubt to anyone?
No, sir.
All right.
Sir, can you just upload the sample paper?
I'll try to upload by tomorrow.
Thank you, sir.
Okay. All right. Bye.